will be presenting on the repair of a particular piece of inactive equipment. This is the Blue M Power-O-Matic 60 batch drying oven that is currently on the first floor underneath the mezzanine. Again, I would be remiss if I did not acknowledge Dr. Henry's involvement and guidance in this project, as it clearly would not have borne the fruit it did without him. And also, he hired a recent graduate, Chase Lemons, during this project, and he has been working on it pretty much non-stop for the past 4 weeks. So a lot of the progress represents his efforts. And I'm going to say a little background very quickly, and it's a very old oven. It's been with the campus at least 30 years. It has not been operated since it was moved to the MCS about 8 years ago. The manual controls were disabled, and it was set up to be operated via the computer and also via the internet through that interface. The interface was designed in LabVIEW, which is used to design what they call a virtual instruments, which are the controlling software. So, environmental health and safety, there were not really a lot of issues encountered. There were some wiring issues early on, so due caution had to be taken when dealing with the electricity. The possibility of hot objects from the oven once it was operational. And water spillage when we were testing the valve system. And also hard hats were to be worn underneath when working under the mezzanine where the oven was. So the way I'm going to be structuring this is as a tour of the various systems of the oven. And so these will really represent the major elements that were worked on over the course of this project. I include the software first because it represented the bulk of the effort and was the first stumbling block in the project too. And then I'll go into a couple of issues in the wiring and then look at the two major subsystems. There's a water valve feeder system that is used to be able to add water by switches that are controlled from the computer into the oven. And then the strain gauge system, which consists of arms running into the oven. Pans can be hung from those, and then the change in the mass can be monitored over time. Then I'll go over a couple of limitations and then state my conclusions and recommendations. Okay. Back when Jessica and I started this project, in the previous project, we found that the software was written originally for LabVIEW 7, which was 2 major releases ago. And a lot has changed going from LabVIEW version 7 to LabVIEW version 2009, which is the one currently used by the school. And even after going through all of the hoops for importing it, there were still very, very many errors that we were working with Dr. Henry to resolve in a very painstaking way. Early into this project, again, he assigned Chase Lemons to start working on it. And Chase Lemons has basically rewritten the entire software, even though the interface is still more or less the same. It isn't that different because his software was designed to do what the original software was doing, but an updated version. This is the front panel that I took this picture on Wednesday, or Friday last week, and this is the one that I had originally intended to base this presentation on, except that I could not stay away and went into the lab yesterday just to see what progress had been made, and this is the interface I see. And I like this one better too because it was actually operational, because on Friday he still had not figured out how to get the software to read the temperature. And now that graph up there is the temperature. There's 2 different thermostats. There's an upper one and a lower one. You can see the faint red line at the top, which is the upper temperature. And the lower one is interesting was just turning it on and allowing it to heat up to about 200 degrees Fahrenheit. There was a difference of about 60 to 70 degrees between those two temperatures within that oven, which is, I found really surprising. So, down here is where the oven heat is controlled, and the temperature is set right there. The 8 switches up here are the water valves, which are, there's 8 different valves to add water into the oven via this copper tubing that you'll see later. And then this is a 0 button. What that does is when you load the weights onto your strain gauge, it's going to give you a certain output. So you want to be able to zero those out, so you start with a baseline. As you add water, then your amount will go up. And as the oven dries, you get the evaporation rate. And at the top here is what they call a watchdog timer. And the way that was originally set up is that you have to activate the watchdog, and it needs an input every so often. Originally it was 15 minutes, where it shuts the system down. I think this is a safety feature because it was designed to be ran over the internet. But Chase, in the meantime, changed it from just an annoying pop-up window that would just come up every 15 minutes to a 30-minute countdown timer that you can reset anytime you want to. So you can just get reset and then walk away from it for 30 minutes. That's really it on the interface. This is just an example of the underlying code that LabVIEW uses to interpret the data. And one of the reasons that you can see up here, this is where it accepts the signals from the strain gauges. These are the, when we were working on calibrating the strain gauges, which again, you'll see that a little later. I just wanted to give an example of kind of the nuts and bolts underlying it that has been worked on. This one was in progress too. One of the things we was doing, these two right here were actually the temperatures. They were connected to the other inputs, which were the strain gauges that have nothing to do with each other, and he was in the process of making another one to treat those as different. He was trying to plot the temperature on the same graph as the weights and masses, and that doesn't make any sense. And then there were a couple of issues encountered with the electrical wiring. The first and most major was that the